Okay, so imagine a mountain, right? But it's not made of normal rock. It's ancient, carbon-rich, about half a kilometer wide, and it's tumbling through the blackness of space. Its name is Bennu, and it has a date with destiny that brings it, well, a little too close to home for comfort.
I know. It sounds like something straight out of a Hollywood blockbuster, doesn't it? But for the scientists who track this stuff, the threat from near-Earth objects is very, very real. And with Bennu, the question isn't really if it could happen, it's more about figuring out what the actual odds are.
So get this, out of the hundreds of thousands of asteroids we know about, there are two that consistently keep NASA on high alert. One is named 1950 DA, and the other is Bennu. It's their size combined with their orbit that puts them at the top of the list of things we're tracking. So let's really dig into what that danger looks like.
So you might be wondering, how do scientists even measure a risk like this? It all comes down to some really specific calculations and a scale that was literally designed to grade cosmic threats. Okay, here's the number that matters. Scientists have calculated that there's a cumulative 1 in 1,750 chance that Bennu will hit Earth sometime between now and the year 2290. Now, I know what you're thinking. That sounds pretty low, but in cosmic terms, that's actually really significant. It gives Bennu the second highest rating we know of on what's called the Palermo scale, which is a fancy way of combining the chance of an impact with how much damage it could do. And Bennu's number, it's high enough to make you pay attention.
So what is this thing we're so focused on? What would it actually be like to see it up close? Well, thanks to an absolutely incredible space mission, we have a ridiculously clear picture.
So picture this. Bennu's about 1/3 of a mile wide, and it's shaped kind of like a spinning top. It's what we call a carbonaceous asteroid, meaning it's packed with carbon. But check out that last number, its density. It's only a tiny bit denser than water. So how on earth is that possible for a giant space rock?
Well, the answer is just fascinating. Bennu isn't one solid chunk of rock at all. Scientists call it a rubble pile. It's basically a loose collection of boulders, rocks, and dust, all held together by its own super weak gravity. So think less like a solid boulder and more like a giant floating gravel pit, with maybe 40% of its insides being just empty space.
This is my favorite part. When the OSIRIS-REx spacecraft actually went to touch down and grab a sample, the surface was so loose that the mission team compared it to diving into one of those plastic ball pits at a playground. I mean, this quote says it all. The only reason the probe didn't just sink right into the asteroid is because it immediately fired its thrusters to push itself away. Wild.
So how in the world do we know all these incredible details? It's all thanks to one of the most amazing and ambitious robotic missions ever launched, NASA's OSIRIS-REx.
You know, this whole mission was a real epic journey, spanning years. It blasted off from Earth back in 2016, finally arrived at Bennu in 2018, and then spent the next 2 years just studying it from every possible angle. Then, in 2020, it pulled off that incredible touch-and-go maneuver to snatch a sample, and just last year, in 2023, it dropped off that precious cargo right back here on Earth. Just an amazing feat.
During that long hangout at Bennu, OSIRIS-REx was basically playing detective. It mapped every single boulder, every crater, using its instruments to nail down Bennu's exact dimensions, its unique shape, and, this is super important, its mass. And all of that data was absolutely vital for the mission's other huge goal, trying to predict the future.
Because here's the thing. If you want to understand the threat from Bennu, you have to be able to calculate its exact path decades, even centuries from now. And it turns out that's surprisingly tricky to do.
The first complication is this subtle but really powerful force called the Yarkovsky effect. It's pretty cool, actually. As Bennu spins, the sun heats up one side of it. Then, as that hot side rotates into darkness, it radiates that heat back out into space. And that radiation acts like a tiny thruster, constantly pushing on the asteroid, ever so slightly changing its orbit over time.
To help you get your head around how small that push is, the science team came up with the perfect analogy. They said it's like having the weight of just 3 grapes constantly pushing on this massive asteroid. It's an almost unbelievably small nudge, right? But you let that happen over centuries, and it can change Bennu's position by thousands of miles. Okay, so the second piece of the puzzle is something called a gravitational keyhole. Here's the deal. In the year 2135, Bennu is going to fly very close to Earth. During that pass, there are these small, very specific zones in space, the keyholes.
If Bennu happens to pass through one of them, Earth's gravity will pull on it in just the right or wrong way to set it up for a collision on a future lap around the Sun. If it misses the keyhole, it just flies on by, no problem. But if it hits it, well, that changes everything.
And this is why that OSIRIS-REx mission was so important. Before we sent that probe, our predictions were fuzzy. We didn't know Bennu's exact mass or shake, so we couldn't really model that Yarkovsky effect with any confidence. But after the mission, with all this incredibly precise data in hand, scientists were able to shrink that uncertainty way, way down and calculate its future path with accuracy we've never had before.
So what did all that new, precise data tell us? Well, it pointed to one day in particular, September 24th, 2182. On that day, the odds of an impact are 1 in 2,700. And while it's still a long shot, it is the single highest probability for an impact that we've ever identified for an asteroid that we've studied this closely.
But you know, OSIRIS-REx was never just about planetary defense. It was also a time machine. The whole idea was to go back billions of years, grab a piece of the early solar system, and bring it home for us to study in our labs.
And man, that sample did not disappoint. When scientists started analyzing it, they found all the key ingredients for life. It had water locked up inside its minerals, it had a really high percentage of carbon, it had complex organic compounds, and then there was a total surprise. They found phosphate, a building block of DNA, just coating the particles.
What this all means is that Bennu is basically a pristine relic from over 4.5 billion years ago. Studying it is literally like opening a time capsule. It's not just helping us understand how planets like ours formed, it also gives a huge boost to that incredible theory that asteroids just like Bennu are what delivered water and maybe even the chemical sparks of life to a very young Earth.
So, we now understand Bennu with a level of precision that is just mind-boggling, from its chemistry all the way to its future risk. But here's the thing to remember. It's just one asteroid out of hundreds of thousands. And it really makes you wonder, doesn't it? What other secrets and what other risks are locked away in all the ones we haven't even visited yet?